Hi everyone, welcome to another video. We are continuing to talk about hyperbolas today, and we introduced in the previous video this one equation of our most basic hyperbolic function. And we also went on to sketch this, and we saw that we explored essentially what this graph did for really large values of x, what happened in the y for really large values of x, and for really small values of x. And we did that on both sides here. And we pretty much saw a really interesting relationship between the two variables of y and x, giving this really kind of bizarre sort of shape. And we noticed that as x gets really big, y gets smaller. As x gets really small, y gets quite big quite quickly. Now, what we're doing in this video, we are going to be sketching some more hyperbolas and looking at two particular transformations. One in which we change the number on the top from a 1 to a 2, and in the second one, where we do the same thing, but also change the sign out front. Now, if you've watched some of the other function transformation videos we've done on this channel, you can probably guess what this negative is going to do, but we're going to approach it really slowly in this video anyway. Okay, so for this first question, y equals 2 over x, we're going to once again just draw a table of values just so we get an idea of what's roughly happening here. And it's important to note as well, on the new graphs that I draw on this axis, I'm going to put in some points of scale to see what happens in the y when x equals to 1 and -1 over here. This will give us an idea of the scale of this particular thing and how it changes, how it changes relative to this particular equation here, our standard hyperbola we introduced in the last video. Okay, so going through this, let's just try some points from -2 all the way up to +2. So substituting in these x values in, the first one I get 2 over -2, that gives me -1. And then I have 2 over -1, that gives me -2. And remember, 0 doesn't work because that means we're going to be dividing by 0. So that's kind of weird, not really going to work. And when x is 1, we get 2. And then when x is 2, we get 1 in the y. So let's actually just draw this in. And I'm going to actually label in some points here. 1, and we get 1, 2, -1, -2, and we'll go to -2. Okay, so when x equals -2, y equals to -1. So let's draw that in here. So we get this thing here. When x equals to -1, y equals to -2. So that's here. And for 0, I get nothing. When x is 1, y equals to 2. And when x is 2, y equals to 1. So we get this thing here. And this is a hyperbola as well, so we're going to just connect these dots. And it's going to, because it's still in this family of hyperbolas, it's going to resemble this a little bit, but you can see that it looks slightly different. It looks like a little bit it looks shocking. It looks a little bit wider here. That's because all of the y values now get scaled by this 2 up here, 2 times. So this value of here in my previous hyperbola, y equals 1 over x, the -1 in the y ended up being -2. So that's why this point is shifted 1 unit down in the y direction. Same thing here. My 1 here gets shifted up to 2 in the y. So we're effectively scaling and stretching out this hyperbola a little bit. And that's the effect of this number here. We're going to explore that even further when we scale up by an even bigger number of 3. We're going to see how this is going to end up looking. Let's draw one more. Once again, just using the same table of values. We should hopefully be pretty comfortable with this by now. But we're going to go all the way from -2 up to +2. So when x equals -2, we have to be careful of the signs here. This is going to be -3 over -2. So those two negatives here, this one and the one up the top, are going to cancel out, giving me a +3 on 2. When x is -1, this is going to give me -3 over -1, which gives me a +3 because of the double negative. Once again, I don't have any values for when x is 0 because I can't divide by 0. And here I get -3. And here I get -3 on 2. Okay, let's draw in some of these points. When x is -2, y is 3 over 2, or 1.5. So that's going to give us something up here. Okay, when x is -1, y is 3. So that's going to be like up here. And 0 we can't have. When x is 1, y is equal to -3. So that's like down here. And when x is 2, y is -3 on 2, or -1.5. So that's going to be about there. So when we actually draw this in, we're going to get something that looks like this. So let's just pause for a second, and first we want to investigate the fact that this doesn't lie. The two quadrants that this hyperbola is in, this green one that I've drawn in, that's different to the other two here. We want to see why that actually is. Now, if we remember from our previous videos, whenever we've talked about negatives in front, this was some type of reflection. Some type of reflection in the y. So it's a vertical reflection. So when we had these in the past, we noticed that everything got reflected around the x-axis. So everything on top of the x-axis went to the bottom. Now, here if I draw this little mirror that's reflecting, we notice that something like this, for example, so this one here, a positive hyperbola in which the sign in front of it is positive, like this y equals +1 over x, that gets reflected in the y here. So what is positive in the y now becomes negative. We're reflecting around this x-axis. And in the same way, the part down here, that is once again getting reflected along this mirror that is the x-axis. And we get something up here. So even just looking at this, we can see that both of my black lines, which correspond to the graph of y equals to 1 over x, both of those get reflected. So my one in the top right here, that is getting reflected. So along this kind of mirror, being above the x-axis, now it is below the x-axis. And the same thing for this guy down here. It's below the x-axis, and now it's getting reflected up the x-axis. So the negative in front, that acts as a reflection in the same way it did for exponential functions as well as parabolas too. And also this 3, that was a process of making the graph wider again. So you can see everything now is being scaled by a factor of 3. So if I just tidy this up a little bit, here I have the coordinates of 1 and -3. So this original y value of 1 from my original hyperbolic function up here, that is getting scaled by -3. So when x is 1, my thing goes 3 units in the y. That's the value of the 3 here. And then there's also a negative in front of that, this reflection that we have down here. And that's what makes this not a positive 3, but a -3. And we get the same thing over here. This is -1, 3. This value of y equals -1 was scaled again up by -3. Because to get from -1 up to 3, I can times -1 by -3. And that is this thing up here. That's what's actually scaling our hyperbola. That's making it a little bit wider. And that's why these shapes, the shapes of these 3 different hyperbolas, look a little bit unique and different. Because the number on the numerator, as this gets bigger, it scales the hyperbola. So as this number gets bigger, my hyperbola seems to get a bit wider. But that brings us to the end of this video, and these are the only transformations we'll be looking at for hyperbolas, because we'll look at a lot more later on in later courses. This brings us to the end of these transformations. We are going to just look at some intersecting graphs and simultaneous equations in the next video. But thank you so much for joining me today, and I will see you next time.